This problem asks you to find the definite integral and the functions given to you, but clearly from 0 to 2, your function have two possible expressions, so you can only express it separately, one from 0 to 1, one from 1 to 2, and then you write down the corresponding structure of the function. Then both pieces, you can use fundamental theorem of calculus part 2 to find it. So you end up with -2 times 1 over 4 plus 1 hence 5 x to the 5, which is your antiderivative evaluated at 1 and 0. Find the difference. Also, it's 1/2 of x squared plus x evaluated at 2 and 1. Find the difference. So what you end up with is -2 over 5 times 1 cubed minus -2 over 5 times 0 to the 5th, not cubed, and then add to 1/2 2 squared plus 2 minus 1/2 1 squared plus 1. So what you end up with is -2 over 5 plus minus, which is 0, and then add up to the first half is 1/2 times 4 plus 2 minus 1/2 plus 1, which is -2 over 5, plus we have 2 plus 2, which is 4, minus 1.5. So you have -0.4 add to 2.5, which is positive 2.1. Be a little bit careful with your calculation if you don't carry your parentheses when you try to do the antiderivative calculation. If it only has one term, you are fine. Sorry, when you try to use fundamental theorem of calculus, if it only has one part, it's fine. If it has multiple parts, your calculation would not work. And the only thing that's special for this particular problem is you want to split it into two pieces to do the calculation. And like we said, net area can be used if the calculation of the region is simple. Clearly, it's an irregular shape. You don't even want to bother to plot the graph. So that's why we go with the fundamental theorem of calculus. You decide which one to use, which makes the calculation most efficient and most